This video explains how to use the Ka calculator in AreaQuant software. To begin, I click on Help, then Show Ka Calculator. So, Ka is the parameter which determines the unit surface area for a given shift in relaxation time between the bulk liquid and the dispersion. And so I need a few bits of information in order to determine Ka. The first thing I need, which is shown here, in this case for a water silica dispersion, is the relaxation time of the bulk liquid that the particles are dispersed in. So because it's bulk liquid, the volume ratio is 0, the volume ratio of particles to liquid, that is. Then in addition, I need at least one data point for the dispersion. In this illustration, we have 3 separate concentrations of the dispersion. And the reason why we do that is simple. We're looking to make sure that the response with respect to increasing surface area and particle concentration and relaxation time is linear. If we see systematic deviations, that allows us to determine the optimum area across which we want to base our Ka parameter. So in this particular case, we have our first data point at 10 weight% silica dispersion. That corresponds to a volume ratio of about 0.048. We measured a relaxation time of 564 milliseconds, so we enter that number in here. Then we do that for a few other concentrations. Over here we enter in the estimated particle surface area from other technique. That could be a BET measurement, that could also be a titration measurement, a particle size measurement, but some other independent analytical technique that we've used to determine the wetted surface area of the dispersion. Exigo is agnostic as to which technique you use. The technique you use is highly dependent on the particle-liquid combination that you're working with. But once you've selected these parameters, the Ka determined from this data set will be displayed here. You can then use that to perform a surface area measurement. And as long as you're using that same combination particle and liquid mixture, just like relative refractive index for laser diffraction, the measurements will be valid and accurate.